the moon attracts the earth moon must be falling. Why isn't it falling? So in order to answer this question, let's take a very simple case of throwing a stone. If I were to climb up onto a very, very, very tall building on the earth, extremely tall, maybe the tallest structure we've ever built, go stand on top of it and just drop a stone, what's going to happen? The stone's going to fall down and reach the surface of the earth. But now, if I were to drop it with some amount of horizontal velocity, in other words, throw it instead of dropping it, with some horizontal velocity, it's going to go and fall a little farther away. I throw it harder, it's going to go and fall even more farther away. I can keep doing this, right? But the fact is, if the earth was flat and went on forever and ever and ever, this probably wouldn't make much of a difference how fast I throw, because it's going to keep landing further and further and further and further and further away. But the fact that earth happens to be spherical means that when you throw it hard enough, after a point, is that stone going to fall? Yes. But is it going to hit? No, it's going to miss, and it's going to go to the other side. And there it's going to start falling all over again in the opposite direction and start coming back over here. And this could keep happening forever and ever and ever if there's nothing to slow down that stone. You've thrown it, it's going to come back, it's going to keep doing this. But what if I try and throw it extremely hard? Right? If I throw it very, very fast, what's going to happen? It's going to go so far away that it's going to escape out of Earth's gravitation. So which means that I can throw it too slow, it falls on the surface of the Earth, or I can throw it very, very, very fast. It goes and leaves the Earth forever. Which means that somewhere in between, there exists one velocity exactly at which I can throw, such that this is going to keep coming around and coming back to the same place over and over again. And because there is no friction to stop it or slow it down, it's going to keep doing this. So in other words, is this stone falling? Yes, it is. But it's just that it's not hitting the surface because it's falling and coming back. Because once it goes to the other side, gravity starts pulling it backwards in this direction. It could go and hit in the bottom part, but if you throw it exactly and precisely in a way that's very well constructed, then it's going to come back to the same place.